Greetings of the day, everyone. My name is Akshat Chaturvedi. This is my summation for assignment 3 of data structure. What is array and linked list and the difference between them? So first, what is an array? Array is a fundamental data structure used in programming to store and manipulate a collection of elements. It is a contiguous block of memory that holds a fixed number of elements of the same data type, for example, integer, float, and char. The positioning is defined by index which starts from 0. Now there are many different types of arrays, but primarily or generally we use two types. First is one-dimensional array and the second is multi-dimensional array. One-dimensional array. It stores elements in row or column method, which is quite simple. Here we have taken example of array of data type integer, which can store up to 5 number of elements. Int a of 5, and it has 1, 2, 3, 4, and 5. These are the elements which are stored in this array. We can also represent this for our own convenience as a of, we have taken a and it has these elements 1, 2, 3, 4, and 5, and the index of these elements are 0, 1, 2, 3, and 4. The second is multi-dimensional array. It stores elements in 2D or 3D formats, or maybe furthermore if it is required. Here I have taken example, data type integer, a, 2, and 2, and the elements are stored in a, 1, 2, and 3, 4, and it is graphically represented as a in this foregrid of 2 by 2, 2 rows and 2 columns, 1, 2, 3, 4. If you want to access the element 0, 0, so it is 1. A of 0 and 1 is 2. A of 1, 0, it is 3. A of 1, 1 is 4. Now you can access any element in constant time by using its index. For example, in the previous example, we have taken a. If I want to access the element which is present at third index, so I will simply write a of 3, and the element which we get is 4. So this all is done in constant time if you know the index of the element which you want to find out. Second is insertion. Insertion at the end is quite fast. For example, if we have an array of which can take up to 5 elements at the most, and we defined it by 0, 1, 2, and 3. There are 4 elements, and we have to give the element which is present at the fourth, means which is at the last, so we will give it as 4, and we print what is the value of index which is present at 4. It would be 4, and the new updated array would be 0, 1, 2, 3, and 4. To insert a element at the middle of an array or at the beginning of array, we have to shift these, and shifting requires order of n, where n denotes the number of elements present in the existing array. For example, we have taken an array of same number of elements are 5, and we have defined it as 1, 2, 3, and 4. So index which is there 1, 0, 1, 2, and 3. These are the index. And suppose we are asked to insert an insert a number between 1 and 2. So that means after index 1 and before index 2. So we want to make this array as 1, 2. Suppose we want to enter element 5, then 3, then 4. So Here first we have to shift 3 and 4 to the right hand side. The index which is presented here, which was given to us, was 1, 2, 3 and 4, and this was empty. So to present an element here of 5, we have to shift 4 to this side and 3 to this side, and then we can insert 5 here. So we have to shift these two elements. So this is a very small example. The total number of elements which are present, which can be present in this array, are 5. But suppose we are given an array of very large number, so we have to shift those numbers to the right hand side or maybe to the left hand side and then insert that number. So it takes the order of n. The deletion part, similar to insertion, deleting from any index except the end takes order of n for shifting. Same in the previous example. In this example, if we want to delete this number 2, which is present at index 2, we have to delete. So after deletion, the index which will look like 0, 1, 3 and 4, means we have shifted this to left and 4 to left. Now what is linked list? A linked list is a linear data structure where each elements are called nodes and are not stored in contiguous memory allocation. Each node consists of two parts, data and pointer. Now data in a pointer can have different parameters. Example, suppose we have to take if we take an example of students in a class. So data can be the roll number, the name of the student, the enrollment number of the student, and then this as a pointer. Now there are different types of pointers. Mainly there are 4. First is single linked list, which is simple. It has one part dedicated to data and second to pointer. This points to the second node, which has data as well as pointer. The second one is doubly linked list, which has 3 parts. First one is the pointer one, we call this ptr1, and this one as ptr2. The ptr1 is actually used to point to the previous node, then here comes the data, and after that ptr2 which points to the second node. And in this one, same ptr1 and here ptr2. ptr1 is used to point to the previous node and ptr is used to point to the next node. Here the next node is not present, so we have grounded it, means we have declared this ptr2 as null. Third is the circular linked list, which is similar to the linked list, except the last node, pointer's next pointer is used to point at the first element of the linked list. This is the last node of the pointer, this was the first node of the linked list, and the last node is used to point at the first node. Fourth is circular doubly linked list. Similar to the doubly linked list, here the last node and the pointer to the last node is pointing towards the first node of the linked list. Linked lists are created by defining a node structure. Here is a pseudocode for the same. Now insertion in a linked list is quite simple. First at the beginning, for example, if we take a linked list, the data here is 3, 4 and 5. Suppose we want to insert a node at the beginning of this linked list, we can simply create a node. We can give this as 7 and point this pointer to the first node of the existing linked list, and we have our new linked list with the first pointer or the head pointer pointing towards the front. And at the end we have to transverse the existing linked list. For example, in this previous example, we have to insert a node at the end. So we have to make a node, we have to give this pointer null or grounded, and the last node of the existing linked list we have to point towards this. We call it 8. Now similar to that, we have, if we want to insert any element or any node at the middle, so we have to transfers to the middle of the existing linked list, and then for example we have taken this, this is 7, 8 and 9. We have to insert 10, we have to insert 10 or 7.5. So 7, then 7.5, 8 and 9. So we will simply point the pointer of the 7.5 node to the node which contains 8. Then we take the pointer of the 7th node to 7.5, and then so on. Now deletion. If you want to delete a node of the which is present at the first or the beginning of a linked list, we simply update the head pointer to the second node head, and then we declare this to null. For the end, it is similar. We have to transverse to till the end. This was the existing last node of the linked list, so we will go till the second last element of the linked list, and we declare the pointer of the second last linked list as null, and then we'll free these two. Always remember, if a node is if you have deleted a node, so you have to free the node, so it takes less amount of space and there is no memory leaks. Similar in transversing, if you want to insert or delete a element or a node which is present at the middle or anywhere between the first and the last node, we will follow the same procedure. Now, what is the difference between an array and linked list? Array are stored in contiguous memory locations. Linked list, whereas stored in non-contiguous memory locations. The size is fixed. The size is dynamic. We can change we can change the size of linked list. Access time is constant time, order of 1. Access time here is order of n. Inserting or deleting an element except at the end involves shifting. In the linked list, there is no shifting required. Memory efficient usage, and here extra memory is required because in array we are taking elements of same data type. Here there are integers, we can take float, we can take characters. All the size of the array, of this array, if we have all the five indexes filled, so it would be integer is 4 into 5, that is the total size of this array is 20. Here the pointer of any data type takes up 8 bytes, and pointer takes up 8 bytes, and the data structure, if we have example integer, we have taken integer, so it would take 4 bytes. So the total memory which this one node alone will take would be 12 bytes. And if we have taken 5 of these, so 12 into 5 would be 60. So here we have 60 bytes in linked list and we have 20 bytes. Hence the memory efficiency in array, whereas in linked list it would take more space. Often used in searching and sorting methods. Searching and sorting, such as bubble sorting, insertion sorting, is very easy in array. And for linked list, my application is used in constant growth and shrinkage. In any application where there's a constant growth, for example, the number of students enrolled in a school or classroom, which is constantly growing and shrinking, some people are leaving the classroom. So in these parameters, we use linked list. Memory is managed by compiler once, allocated. Memory is dynamically managed and can lead to memory leaks if not handled correctly. Now, this is the last difference which I think should be there, that arrays are easy to understand, whereas linked lists are quite complex to understand for a beginner programmer or who is simply learning DSA. So I think array is an easy topic to understand, where linked list is quite complex. Thank you.